Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. Let me introduce myself first. My name is Safira Aulia Libertin. My number student 410-141-9002. I am from International Class of Mathematics Education Programs 2019, Universitas Negeri Semarang. Before we go to the main content of this video, I wanna say thanks for visit and watching this video. Here, I want to explain how to solve the mathematical problems, especially about linear programming by using Geogebra. I had to choose one problem. A company produces two different products. One of them needs 1/4 of an hour of assembly work per unit, 1/8 of an hour in quality control work, and $1.2 in raw materials. The other products requires 1/3 of an hour to assembly work per unit, 1/3 of an hour in quality control work, and $0.9 in raw materials. Given the current availability of staff in the company, each day there is at most total of 90 hours available for assembly and 80 hours in quality control. The first product is described as a market value or sale price of $9 per unit, and the second product described as value of $8 per unit. In addition, the maximum amount of daily sale for the first product is estimated to be 200 units, without there being a maximum limit of daily sale for the second product. Formulate and solve graphically a linear programming that will allow the company to maximize the profit. Okay, we want to find the maximum profit. Here the solution. First, we define whose thing over which have to control. In this problem, we have direct control over two units of production. We define this variable by symbol x and y, where x is the product 1 to be produced daily and the y is the product 2 units to be produced daily. The constraint for this case that represent the daily assembly time, availability of time for quality control, establish an upper bound for the manufacturing and daily sales of product 1 are 1/4 x plus 1/3 y less than or equal 90, 1/8 x plus 1/3 y less than or equal 80, x less than or equal 200. Because there are production that produce negative units, then the constraint for negativity condition are held. They are x positive and y positive. The goal is to find the maximized profits. So the objective function in this case represented by letter z is equals to 7.8x plus 7.1y. Okay, I have to find the visible area of all the constraint. The next we want to find the vertex of the visible area. We find it by the intersection of two graphs. We have point A and point B. The next we have point C, then point D, and the last we have point E. So we have 5 vertex for the visible area. The next we must define the objective function, that is 7.hx plus 7.1 y equals, we denoted the value by letter K. Yeah, I'm sorry, I have mistake here. Okay, it's clear. Then we've defined the interval here. K is greater than 0 and less than 3000. Okay, the maximum profits is the point that through with this objective line. Okay, we apply this. The first is point A, the second point that through in this line is B, the next E, D, and the last is the point C. Yeah, point C. So we get the point C as the point that have a maximum profit. The maximum profit that the company obtain for this case is 2,140, where x is equals to 200 and y is equals to 120. Okay, that's all of this explanation. I'm sorry if I have some mistake here. I hope you are understand, and see you. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.